Hi everyone, welcome back. Let's see the concept of deadlock detection. Guys, deadlock detection is one of the strategy of deadlock which is generally used for to check whether deadlock existed in the system or not. For that reason, we are using deadlock detection concept. So far we have seen various kind of concepts. Among those, we have already seen how to detect a deadlock. Have you remembered it? So if you want to detect, how can we detect it? Tell me. Generally, I have discussed the concept of single instance resource request gap, or I can say that single instance resource allocation graph, right? So here I mentioned whenever there is a cycle exists, definitely there exists a deadlock. Coming to one other way of approach is like multiple instance resource allocation graph. Can I say that if a cycle exists, I can't guarantee deadlock is existed, but we can say that if a deadlock is existed, cycle is definitely existed, right? Which means that if a cycle existed, deadlock cannot be guaranteed. That's the reason what we can do now, as we cannot able to confirm with respect to cycle, we can run simply safety algorithm. So in order to detect an algorithm, or in order to detect whether it contains a deadlock or not, first we are going to check with whether it is a single instance resource allocation graph or not. If it is single instance resource allocation graph, we are going to check for cycle. If cycle exists, then definitely deadlock is existed. Otherwise, if it is a kind of multiple instance resource allocation graph, we are not going to check for the cycle because we cannot guarantee deadlock exists or not. That's why we can able to simply run the safety algorithm, right? For example, there are 5 processes are there: P1, P2, P3, P4 and P5 are the 5 processes are there, and already allocated various resources for this process like ABC in the form of 010, 200, 303, 211, 002, and which is requesting various resources like ABC resources. So the requesting resources are 00 for process P1, and for process P2 202, and 000 for process P3, 100 for process P4, and 002 for process P5, guys. And they are saying that the maximum resources which are available in the system are 7, 2 and 6, right? Based on this, we have to define whether the system is in safe state or not. So if I am saying that whether it is safe state or not, if it is unsafe, can I say that deadlock exists? Yes. That is where the concept of deadlock detection algorithm is working, right? So in order to apply the safety algorithm, we have seen various kind of examples in the previous class also. We have to find availability of the resources A, B, C in the current system, right? So request I can also call it as need. And what are the available so far, right? So we have to subtract it from the what are the resources which are allocated so far, right? So which means that this will be 6 and 2, this will be 7 to 6, right? So far total allocated are 7 to 6, and total maximum resource available for us at any time is 7 to 6. So how many are available then now? 0, 0, 0. Can I say that system is in unsafe state? No, we can't guarantee. Just check with the request. What are the requests that are, is it satisfied? Yes. And there is one more thing which is satisfied. This is also satisfied. And the remaining all are not satisfied. So we can start with either P1 or P3. So for example, I am trying to maintain the safe sequence P1. If P1 is requested, then it will be allocated and it will process it. It will release the resources 0, 1, 0. If it releases the resource 0, 0, 1, 0, 0, then availability is 0, 1, 0. Now can I satisfy any other process? Just check with, is P2 satisfied? No. Is P4 satisfied? No. Is P5 satisfied? No. But what about the P3? Yes, definitely satisfied. So after certain point of time, P3 also released the resources, that is 303. So 313 is the still availability. So P3 got the chance. Now check. Does any system allows to execute further process? Yes. Check with the P2. Is 202 is less than or equal to 313? Yes, satisfied. Then I can simply allocate, release these three things, which can be like 513. So P2 is satisfied. P2 is satisfied. Then 513, can I satisfy with P4? Yes. Good. Then 211 is going to be released, which means 724. So which I can say that P4. Then obviously 002 is the request, so 002 is released, which means 726, which means that P5. So as all the processes are completed, the system is in safe state. Is there a deadlock? Is there? No, right? We are simply saying that deadlock detection, whether existed, not existed. If you are able to answer it, can we say that deadlock detected or not? Yes. That is where we can apply simply safety algorithm for the deadlock detection also, right? So this is the only answer. This is the only safe state that we are going to get? No. You can get various safe sequences. It might be one or more for this example also. Okay guys, so you might think that it will fail for detecting the deadlock, right? So as it is success. So for example, I am trying to change the request. For example, this P1 is requesting for 000 and P3 is requesting for example 021. So for example, the availability of the resources, total availability of the resources generally are 7 to 7, and the remaining thing are all as usual. Then how many are totally allocated? It are 7 to 7. Then what about the availability of the resources? Right now will be 001. Now can you able to run the algorithm? Yes. First, does 000 is less than the 001? Yes. So P1 is satisfied. When P1 is satisfied, 010 is going to be released. Then you are going to get 011, right? Does any process request less than the 011 resource? Try to check. P2 can't guarantee, can't get. Does 021 is less than 011? No. Does 100 is less than 011? No. Does 002 is less than or equal to 011? No. Which means that no other process except P1 are unable to move further. So we can say that there exists deadlock. Deadlock existed for the updated data set. That is where we can apply the deadlock detection algorithm. Right? Hope you understood this particular algorithm. Thank you.